So we have discussed different ways of executing Python program. We have executed our hello world program in multiple different ways. So coming back to our block diagram, there is one thing which is something we have not seen so far, the machine code it generates. So let's have a look at what we have seen so far, just like a review. So we have seen the Python part, the program. So this is the program part. So this is something we have done in Notepad and VS Code or Visual Studio Code. So VS Code is nothing but Notepad on steroids. It has a lot of different functionality like debugging, etc., etc. We will be using this in future, and we have seen the online Python as well, which is the easiest and most convenient, but for advanced use cases it's not good or it's not fit. So we'll be using Visual Studio Code. And then we have seen the Python as well. We have installed our Python runtime or Python interpreter, Python, just Python. We have explored the folder and all that kind of stuff we have done to see what is inside that box. So this will convert. So this is the converter program. So this converts into what? The machine code. This thing we have not seen so far. And this is, let me give you a heads up, it's a scary thing. And that's what we are going to do next. So next demo, I'm not expecting you to do. It is just for display purpose. I am not expecting you to do. In fact, I recommend not to do as well. This is a scary bit. If this is not going to scare you, I don't know what will. So let's have a look at what is really executing in the CPU. So what CPU is going to get. So I'll be using certain tools, certain advanced technique to show you this machine code part. So I'll be shortly explaining you. We won't be getting into the details of it, but we will just explain and show you there is a non-human readable part is being created by this particular program and this module, which is Python. Again, if you're not able to understand anything in this demo, nothing to worry. Just I'm proving this particular box is there and it exists. That's all. Anyway, let's get into it and let's see how it goes. So this is our Python application, the hello world. I have made some modification to it so that it won't end pretty soon, so that I can attach a debugger, a native debugger. So don't worry about it. What is a debugger? You can think of it like a scanning or a MRI or a CT scan I'm doing on the program. So we will see Python debugger, but we won't be looking at native debugger in this training. But what I'm going to use is a native debugger to see what is inside the Python. So what I'm going to do is I'm going to download and install something called native debugger or WinDebug in Windows. So again, I'm not expecting you to do it. In fact, you don't have to do it. Just wanted to show you. So I'm going to download and install it from the Microsoft Store. As usual, Microsoft Store takes its own time. So this is the tool. It's called WinDebug. So this tool is used for debugging the operating system and things like Python itself. So it's a pretty advanced software as far as Windows is concerned. Probably the most powerful software in entire Windows platform. So it's a native debugger. I'm downloading it, installing it. It is from the Windows Store. So I have started it after installing. So this is how it looks. What I'm going to do is I'm going to execute our Python program. So it has executed the hello world and I have an input pending. That's why it's not exited. So what I'm going to do is I'm going to explore that particular program from the debugger. I'm going to attach to that Python. So this is a Python executable, which is executing the program, which we are executing, the Python hello world program right here. If you look, it is the same location right here. Let me highlight that for you. So this is the location we've been looking before, the Python code as well as the Python executable. This is the hello world. It's the same command line I have executed. There is no difference. All I'm doing is going to inspect this code from my debugger. So the debugger is what you're seeing here. So this is the debugger. or the native debugger or the software which I installed, this is going to attach into this, or it is going to inject itself into this Python code so that we can see what is going inside that. So we are trying to look into this Python. So I'm going to attach with the debugger. So it is attached successfully. So this is how it looks after a successful attach. So this is how the program looks. As you can see, the program is right here, the Python. So from the native operating system perspective, operating system doesn't know anything about our Python code. It is only aware about the Python application itself, which is converting the Python code. Now let's straight to get into our business. What we are looking to achieve here is we want to see the machine code of this program, or what our hello world has actually created and executing on the CPU of this laptop right now. So that is what we are trying to figure out. So I'm going to type a couple of commands here, nothing to worry. So there are a couple of commands which you don't have to know anything about. So basically, after I have typed a couple of commands, what I'm seeing is this particular function. And so where is the binary? This is the binary generated by our hello world approximately. There is a little bit more as added by the runtime itself. I'm not getting into the details, but this is the approximate equivalent of the binary digits our program has created and giving it to the CPU. So how do I know that? I know that from this particular line. So this read line is corresponding to the input which I have given in the program. So let's have a look. So I have an input right here in the program, and that input is corresponding to this particular line in the assembly language or the machine code. From that, I'm assuming with some other commands and stuff, this is the machine code generated by the Python runtime. And this is given in hex format or 16-bit digits or 16-based digits. It is very common in representing binary numbers, but these are the binary numbers which is going to the CPU of this laptop to execute this program, this Python program. That is a highlight. So the binary code equivalent to this particular program is given here, and it is created by the Python runtime. So let's quickly review what we have done so far with the help of a block diagram to make things easier and clearer. So we have created our Python application. This is our Python application, which is nothing but our hello world. We have created it with the help of Visual Studio Code or Notepad, whatever editor we are comfortable with. Then we have passed it to the Python runtime. So this is a python.exe. So we have passed it to this particular binary, and this binary has converted it into machine code. I'm going to put MC, and it is given to the CPU. So this is the CPU sitting here with all the legs. And this machine code is not very easy to see. So what we have introduced into the equation, a very tough guy. What is his name? Called native debugger. I'm going to call it ND. The name of the debugger, if you want to remember, it's called WinDebug, not necessary to remember at all. So this NT, we have installed this guy and attached to this thing here. In fact, we attached to this thing to see this. So let me redraw that arrow. So we attached to this python.exe here, and we saw the machine code inside this using the native debugger. That's what we have done. And we saw the equivalent. So there is this print hello world. I'm just putting it hello. The equivalent binary digits created by this particular Python executable or the Python runtime, we have seen that inside the debugger. So debugger is nothing but a scanner. You can think of like a MRI scanner or a CT scanner or an X-ray. Even some of the debuggers have the name X-ray. X-ray of what? X-ray of the program which we are debugging. We'll see debugger, the Python debugger, not this debugger. This is the first and last time we will be dealing with this debugger in this training. So as I mentioned, don't do this demo. I have not even given enough information for you to try this demo by itself. I just wanted to show you the binary digits created by the program, by the Python runtime. That was my only intention. Now coming back to the slides, we have seen this one bit very clearly. So we have seen the digits, and those are the digits which is going into the CPU. The digits were 16 based or hex digits, but hex digits are normally used to represent binary numbers in all kind of display purposes, because otherwise it'll be getting too big. But those digits you are seeing is nothing but the binary numbers which is going into the CPU to show that hello world.